Let me show you some damping here. So let me just watch the motion of this thing, right? This thing has a Q factor of 40. We'll talk about that later, but that means it's going to go about 40 times before it stops. And you can watch this thing oscillate. Notice that this is a bit of the envelope of this. If we just imagine a line drawn like this, that envelope is kind of like an exponential decay. In fact, that's one of the models for this, is that it's an exponential decay. And the reason for that is that the force actually, damping forces tend to depend on the velocity of the mass. And at first the mass is moving quickly, so it loses energy quickly, right? It's moving quickly and the force is large and therefore it loses energy quickly. Later on it's not moving very fast, so it's not running into very much, for example, air or oil or whatever is damping it, right? Since it's not moving very much, it's not losing energy as fast. Okay, so it loses energy quickly at first, more slowly at the end there, right? And that's because the damping actually depends on the amplitude and the velocity. Okay, let's take a look at this guy here. Okay, and let's change our driving period. Let's change our damping to say, I don't know, 0.2 or something like that, right? And let's run this. So now we're starting off the oscillator, and this is sort of the opposite of it, right? So at first, there's not very much damping force because it's not moving that fast. And so as we add energy to it, it's gaining energy because it's gaining energy faster than it loses energy, right? But watch what happens along about 40 seconds here. It starts to have a big enough amplitude, which means its velocity is higher and it's also moving more distance, right? And so along about 35 or 40, I think it's still getting bigger, just slightly, right? For sure, like about 40 seconds here, it just plateaus. And the reason is now we're giving it energy at a certain rate. Maybe it's like 5 watts, right? But it's losing energy at 5 joules per second. So it's stabilized. This is an equilibrium, right? So before, what we can say, and then this is on the IB test question that we looked at, from 0 to 40, the amplitude's small, so it's losing energy rather not very fast, right? So therefore, it's gaining energy. We're giving it energy, more energy than it receives, right? Beyond 40, though, it's oh, it looks like it's bigger here, right? Beyond 40, though, it's losing energy to the damping as fast as we're giving it to it. So the amplitude won't get any more. Okay. Now I can mess with this, right? If I can just make that 0.1 or 0.01, well, that's really small, right? How about 0.05? We'll try that. And this, of course, is going to, there's less damping, right? So it's going to go to a bigger amplitude. It's going crazy. It's going to eventually hit equilibrium, right? But the amplitude might be quite a bit larger. In fact, this is just going to go right off our screen there, right? But it will eventually reach an equilibrium. Just not on our screen. I like how it's writing outside the box there. Anyway, that's the concept with damping, right? Damping is a force that depends on the velocity that slows it down, takes energy out of the system.